Hey, what's up, everybody? Welcome back to Hacking Smart Contracts for Fun and Profit. Next, we're going to look at challenge number 3, Truster from Damn Vulnerable Defi. So, more and more lending pools are offering flash loans. In this case, a new pool has launched that is offering flash loans of DVT tokens for free. Currently, the pool has 1 million DVT tokens in balance. You have nothing. But don't worry, you might be able to take them all from the pool in a single transaction. Okay, let's check out the contracts. Okay, here we have the flash loan contract. So once again, we're inheriting from re-entrancy guard. We have a variable at the top here, damn vulnerable token, which is an IERC20 token. On our constructor, we're just initializing the token. And then we have the meat of it here. We got the flash loan. So in our flash loan, we got a couple inputs here. We got borrow amount, borrower, target, and bytes call data. So this is really what's going to be the interesting part of this. Next, we can look down just a little bit further. We're doing a check to make sure the requested amount is enough. We have enough tokens in the pool. If we have enough tokens, we'll initialize the flash loan. We transfer to the borrower for the borrowed amount. And then here we call the function call data, which is just this arbitrary call data. We call it on the target, which is going to be the token. And then after that, we do a check to make sure the flash loan has been paid back. Okay, cool. That's pretty much it. So really here what we're looking at is the novel part of this challenge here is the bytes call data, which we can input arbitrary data into. We can just put whatever we want in here. So what we're going to do is we're going to put a payload to approve this contract for the token. And that's going to allow us to just be able to transfer tokens from the pool to wherever we want. So that's going to be the attack vector for this contract. Let's get into it. Let's see, at the top, I'm just going to copy a bit of this here, get us going. Okay. So first we'll need an interface to the lending pool. Usually interfaces, you start them with I and then you call them whatever you want. I'm going to call this Truster Pool. And then we'll grab the function we want to interface with, which is this flash loan function. Just copy that, bring it over here, and then end it with a semicolon. And then this is our interface setup. Pretty simple. Next, we're going to go down. I'm just going to start the contract here. It's called Truster Attack using address for address payable. And then we're just going to set up a couple variables here. We're going to do one for ERC20 called token. We go one for the Truster pool called pool. And then we're going to set one up for the attacker EOA. Okay. Now we're going to do a constructor. Constructor. We're going to initialize these variables in the constructor. ERC20 token. What do we call it? Truster pool. Truster pool. Underscore pool. And then address, gonna be underscore attacker EOA. Okay. initialize them like so. Token is equal to underscore token. Pool is equal to underscore pool. Attacker is equal to underscore attacker EOA. Okay, now so we've initialized all of our variables. Did I spell this wrong? Truster. Oh, one too many O's. Truster pool. Okay, there we go. So now we can just create our attack function. Call it attack. We don't need any inputs in here. We need to make it external. And then inside here, first what we're going to want to do, we're going to get pool balance. Create a uint 256. Call this underscore pool bal equal to token dot balance of address pool. Okay. Next, we just want to call flash loan. Call the flash loan. So now I'm going to go pool dot flash loan. What I like to do here, so the borrow amount, we don't have to borrow anything, because really what we want to do is just trigger this data, and the data is going to just be our approve payload, which will approve this contract, and then we can transfer tokens out of the pool after we're approved. So borrow amount, we don't need anything. We can just go 0. The borrower is going to be the, it could be, I don't know if this matters actually. It could be anybody because it doesn't really matter. We're not borrowing any money. So it should just work. Attacker EOA, the target is going to be the token. And then data, we're going to do an encode with signature right here. So really what I like to do is separate these down onto different lines. Just makes it a little cleaner, easier to read. Put this down onto its own line. So we'll close off the function here. So token, so this encode with signature, we can pass in a function signature, which can be called onto like from another contract basically, and then we can pass in our own data, and then it will reference that function and call it for us. So the signature we want to call, it's called approve, and this basically it needs to have it needs to be set up in the same way in which the function we're referencing is calling. So the approve function has an address, and it takes in a uint 256 here, and then as the argument, here we put in the arguments. So for the address, we want to reference this contract, and then for the uint2, so basically it's approving what address do you want to approve and for how much. So we want to approve our address, this attacker address, for the total amount of the pool, which is pool bal. Okay. Oh, I forgot. You got to close off the quotations here. So that looks good. Okay, that looks good. So this should, when we call the flash loan, token Y. Oh, I need I need to wrap it with the address. Okay. So this should trigger a flash loan, and we should trigger this approve payload. So after this successfully executes, we should have this attacker contract should be approved, and we should be able to transfer functions from the pool into our attacker EOA. So that's what we're going to do here. We're going to just say transfer tokens to attacker EOA. Okay. So we'll go token dot transfer from. We want to transfer it from the pool to the attacker EOA for the, we can just do the pool balance, I guess. We're gonna, yeah, for the pool balance. Okay, that should be it for the contract. Let's go into the test file. So here we're just doing some basic setup, initializing the token, the pool, deploying the contracts. We transfer some token into the pool, and we just do some checks on the balance of the attacker and the balance of the pool. Okay, so here we're gonna put in our exploit. We're gonna say that this dot hack equals await. We're gonna await ethers dot get contract factory. It's called truster attack, and we're going to be deploying it by the attacker, and then we deploy. So we can string all of these are different functions we can actually string together here, which is quite convenient. I think it's a little cleaner. Before I used to do this kind of separately, but I realized you can actually just string some of these functions together, and yeah, it just looks a little cleaner. So we need to look at the order here. We did token, pool, and then attacker. Okay, so we need to do it in the same order. This dot token dot address, this dot pool dot address, and then just attacker dot address. Okay, that should be good. So we are basically here, we're initializing the contract, and then we're deploying the contract all in one function here. And then after we have it deployed, we can call it. We can just say this dot hack dot attack, and then that should be good. We don't have to pass any variables or anything to it because all the magic is happening inside the contract. Let's try it out. Let's hack it. With the terminal, so yarn run. We want to run truster. Truster, let's do it. Come on, baby. Waiting, waiting, waiting. Oh, passed. And we hacked the contract. Okay, so that's it. Thanks for tuning in to this episode, and we'll check you on the next one. Boom.